Practical question is like this. We ask you the graphical presentation of those solutions of the points fulfill all this requirement, fulfill all these three constraints. So we try to change it to slope-intercept form first. Once we can use the slope-intercept form, we can draw the line within a very short time. That means we know the boundary, then we can separate the region. The first inequality, x minus 2, y plus 5 is larger or equal to 0. So just put y alone. And then both sides divided by negative 2. And its trigger change in the direction. Be careful about that. Y is smaller than 1 over 2 times of x and then plus 5 over 2. We are now going to draw the line. In this slope-intercept form, this is the slope, while this one is the y-intercept. So we know the y-intercept is 2.5, 5 over 2. And then it's going up slowly because the ratio is every 2 steps to right will go up 1 step. The line is approximately like this. Beware that I use a solid line is because this one accepts the equal case. And you should write down the name of this line. This line is the first equal case of the first inequality. So y is equal to 1 over 2x plus 5 over 2. And the required region here is talking about y should be lower than this reference. So we are talking about the below region. Now after this, the first constraint, the feasible region is the below region. And this region is infinitely large below it. You can even choose any point with x equal to 0 and y equal to negative 10,000 or even billion. Then we work on the second equation. Similar calculation. Negative y is more than negative 4x plus 8, and then that's why y is larger or equal to 4x minus 8. Now we have a y-intercept, negative 8, maybe approximate here, and then slope equal to 4. That means every 1 step to right will go up 4 steps. So it's quite steep. Therefore, it is approximate like this. And again, please write down the name for this line. This is the equal case, y equal to 4x minus 8. And then we are going to find a region satisfy this requirement. Y larger than, that means higher than the reference. So we are going to choose the upper region. The second constraint is the above region. But however, we are talking this symbol, that means in case. We have to fulfill both requirements. So this one just fulfill the second but not the first one is not okay. Or to be more simple, that means this region is excluded. Only this region. This left bottom region is feasible at this moment. Therefore, the updated region is this region. We are now going to work on the last constraint. 3x plus y plus 1 need to be larger than 0. Y is larger than negative 3x minus 1. Beware that we don't accept the equal case, so this time we will use a dotted line. And then the reference line is negative 1 y-intercept. And then go down quite quickly because the slope is negative 3. But not as quick as the previous line. So this line is a dotted line, and then this time we're talking about y is larger than this reference line. So we are talking about above this region. This time, this triangle region also fulfill requirement, but the bottom region are excluded by the third constraint. That's why only any points within this region will fulfill three requirements together. So if this is some reality constraint that we can't choose beyond this region, then we can choose some feasible. This is called the feasible choice for x and y. And in this section, your mission is I give you some constraint here in inequality format, and then you are going to draw the line on the coordinate planes, and also you need to find out what is the solution region to satisfy all this equation. It's not necessarily limited in a closed region. It may be an open region somewhere here. It depends on the requirement.